here the Mekong Delta with its three main river arms of the Mekong, and the southern part we're having the low elevated flat southern Mekong Delta. And the processes become more clear if we look at a simplified cross-section. The mean surface elevation is just about half a meter above sea level. So sea level rise of 0.3 centimeters per year already is significant for the people living there. However, the land subsidence has a rate of 3 centimeters per year. It's 10 times as strong as the sea level rise. And this has a huge impact on the people's life, because if those processes continue as they do, within the next 20 years, most of the southern Mekong Delta will be below sea level. And thus, it's a really big danger for the millions of people who are living there. So, and the main question is, what are the drivers for this land subsidence processes? One possible driver is the groundwater extraction that leads to a decline of the groundwater level and thus to a compaction of the aquitard clay layers. But a second possibility is also climate change in general. In particular, the longer dry periods may lead to a shrinkage of the clay layers in the top, but also the construction of dams can cause the land subsidence because it's just hindering new sediments to come, which before compensated the natural compaction processes on top. Of course, we also have to mention the building activities which lead to local subsidence below the buildings. So if we just wrap up the physical processes behind, on the one hand, it's the compaction of lower clay layers due to groundwater exchange. That's approximately in a depth from 20 to 300 meters. And we're having the shrinkage of the upper clay layer due to the change in water content that happens, let's say, in the upper meter. So, and in my PhD, I developed a concept where I want to monitor the processes which trigger the land subsidence as well as the land subsidence effects themselves. I want to carry out lab and field experiments to determine the relevant parameters which are describing those processes. And based on that, I want to set up a numeric model to be able to predict land subsidence and do calculations what we can do to minimize or even stop those processes possibly in the future. So as today's lecture is about soil moisture modeling and monitoring, I'm focusing more on the second part here. And for that, I would like to introduce the pilot site that the colleagues of mine together with me, we installed in December 2022, where we set up a multi-parameter monitoring site in the southern Mekong Delta. So we're having soil moisture sensors. You can't see them because we installed them underground, of course. I will talk about the data from those soil moisture sensors more in detail later. We're having 3 groundwater wells in 3 different aquifers in a depth up to 250 meters. We're having a weather sensor which is collecting many parameters concerning weather data. Also, I will show some of that data as well. And what you see here in the front, we're having a so-called subsidence observatory, which is a drilling up to 160 meters depth. We installed sensors in 8 depth, which are detecting the compaction processes and the subsidence in a very, very detailed level. Here in the center of the pictures, you see a corner reflector. We use that to monitor, to improve the evaluation of satellite data concerning land subsidence. Just for completeness, we are having here the energy supply for the sensors in the right. So in general, we can see the 3 sensor types we're having here on the left that are monitoring the processes which are triggering land subsidence. And here in the front, we see the monitoring systems which are monitoring the subsidence itself. So to wrap it up, we're having an automatic monitoring of the relevant processes and of the effects. We're having an automatic daily data transmission to our server, so I can see the data every day. And by this, we're having the first time the possibility to get a full picture of the process dynamics. And in particular today, I would like to talk about more in detail about the TDR soil moisture profile sensor that we installed. It's measuring every 15 minutes the volumetric water content, the temperature, the bulk electrical conductivity, and this not only in one location, but in depth from 5 centimeters to 100 centimeters. It actually looks like a giant screw that we screwed into the earth, and it's measuring very detailedly the listed processes. So I would like to show the first monitoring data that we obtained since installation. We see here in the mid of December, we started installing the sensors, and the data set ends last week when I started to prepare today's presentation. In yellow and orange, we see the soil moisture sensors in the upper part in 5 and 10 centimeters. However, in the blue colors, we're seeing the more deeper locations of the soil moisture sensor. In general, we can see nicely that we're having high dynamics in the upper part, while the deeper layers are having low responses on and low dynamics. The same is also for the temperature that the sensor is detecting. In 5 and 10 centimeters, the amplitude of the daily temperature variation is still high, and obviously it's decreasing with depth. And we can see in around 60 to 75 centimeters, we are already around mean annual average temperature, which is in Vietnam around 28 degrees. So it's definitely much closer to Namibian temperatures than to German temperatures. It becomes more interesting if we also look at the precipitation data from the monitoring station, from the weather station. We see we're having a high precipitation event here, when also the soil moisture is rising at this point in time and it's decreasing after that. The same is also happening after that precipitation event. However, we're seeing other events, for example, like here, in 30 centimeters depth, we're having an increase in soil moisture that we cannot really attribute to a precipitation event. However, this becomes more clear if you also look into the bulk electrical conductivity. We see parallel to the increase of water content, we're having an increase of electrical conductivity. And this is due to the fact that we are having in the southern Mekong Delta many rivers and channels and ponds which are operated by mankind for irrigation purposes mostly. And the water of those channels is very saline because it's so close to the sea. So we can see this water here, which is pointedly increasing in 30 centimeters depth. The water content is due to an inflow of more saline waters from channels and ponds, which are very close to our monitoring location. So now I plotted here the subsidence data, the most upper sensor, which is measuring the subsidence above 13 meters. That means so from surface elevation to 13 meters below ground. And if we look here at the dynamics, we see that there is a rising, that means an uplift of the surface elevation in terms of an increase of the water content in this period. We're having subsiding processes, that means subsidence after that when the soil moisture is decreasing. And also we see here in terms of that rain event that caused here the increase of the soil moisture in the upper part, we also see an uplift of the subsidence. Of course, we have to consider, as I mentioned before, the data is very precisely. So the total scale here is 0.6 millimeters. So we can also see the daily dynamics, which are also corresponding to the daily dynamics of the water content, which is like a really unique data set and very helpful to understand the process dynamics of land subsidence. So after that short introduction to the monitoring data, I would like to give you an introduction on my modeling approach that I actually just recently started to work on. And in principle, I wanted to start as simple as possible in the beginning. So I set out a one-dimensional model for a 1 meter soil column. And I applied a uniform soil type with standard values for clay. So the material values are at first used from literature values. The boundary conditions, I set precipitation on top that we have from the monitoring data, and we have evaporation. In the first simple step, I did not consider transpiration at all. And in the lower boundary of that 1D model, I implied a sealed boundary, so there is no seepage. That we already had seen before in the monitoring data. The lower elevated sensors are not having any dynamics, so I think this assumption is for a first simple modeling quite justifiable. So the math behind, I would like to shortly introduce it. So it's actually not so complicated. It means just the change of the water content theta over time equals the change of the fluxes Q over the column Z. So, and if we look a bit more in that flux term, we see the fluxes are depending on the hydraulic conductivity K, which itself again depends on the water content theta, and the pressure gradient over the column Z. And this pressure gradient also, for example, considers suction, and there it comes into play that we are considering standard values based on the Van Genuchten soil moisture parameter model. So to start the model, I said we already used the standard values for the material for clay for the Van Genuchten model. We're having the precipitation data from the sensors. So all we need to do to run the model is to calculate the actual evaporation. And for this, I used the weather data that we obtained on site. So I just plotted some of the parameters which it's monitoring. For example, the barometric pressure is here. We're having the wind speed, the wind direction, we're having the air temperature, we're having the relative humidity and the radiation. All this data is recorded in a 1-minute interval. And from this data, we can calculate the evaporation flux based on the Wilson-Penman equation. Basically, if we just look at the terms on top, we see the terms which are favoring evaporation, and on the top we're having the terms which are, so to say, hindering evaporation. For example, the term Q, it contains the radiation. That means the more radiation we have, the more evaporation we can have. Also, this EA term, it contains the wind speed and the wind direction. That means the more wind we have, the more fresh air can come, which makes it more easily for soil moisture to evaporate. This A term here in the bottom, it contains the relative humidity. That means if the air already is highly saturated with water, it's more difficult for soil moisture to evaporate. So based on this data, I calculated the actual evaporation on a 1-minute basis that I plotted here. Below, I plotted the precipitation data that I showed before. As you see, it's quite difficult to compare this data, so I plotted it also in a cumulated plot with which shows that we have 40 millimeters of precipitation since mid of December in our location, and we calculated the actual evaporation to 220 millimeters by now. So with this data, I run my first simple 1D model. The results you see here on top. In general, the dynamics are met. For example, we see here in terms of the precipitation event, here we see an increase of soil moisture in 5 and also in 10 centimeters in terms of precipitation event. However, we see that the deeper soil layers of 30 and 40 centimeters are not responding in our model here as much as they do here in our monitoring, and let's say, so to say, in the real world. So of course, we cannot model with that 1D model those processes here, or for example, also those processes there, because they are forced by lateral inflow, as I described before, from the rivers and the channels. So to wrap it up, probably someone of you has already recognized it. The scale of the water content from the monitoring data is currently not really realistic. This is due to the fact that we are having a very, very high clay content and a very, very high organic content in the soil, which requires a soil-specific calibration of the sensors. This I will carry out in my field trip to Vietnam in April 2023. So basically, this graph here, it will still look the same. This one here, however, just the y-axis scale will change after the calibration. For the model, as we saw before, it's important to refine the soil layer characteristics. We saw before here, in particular in the 30 centimeters, there is definitely a reaction which is not linearly linked to the other soil layers. So we need to discretize the soil layers more detailedly. In particular, I want to carry out a characterization of the soil-specific soil-water characteristic curve. For that, I want to take soil samples from the relevant depth and bring them to Germany to evaluate the soil-water characteristic curve as well as the hydraulic conductivity. And in terms of improving the model, I also want to consider transpiration in the future, and I want to enhance the model to a 2-dimensional model, which also respects the interaction with the ponds and the channels. So that was my short presentation. I hope I was in the 15 minutes timeline. And just in the end, for those who are curious, here I've just plotted until today in the morning. I got the recent data from the Subsurface Observatory. The upper sensor data we saw already in the presentation, and here you see the monitoring data of the subsidence processes which are happening in lower depth. But in case you're interested in that, we can talk about it more in the discussion. But again, thank you very much for your attention, and I'm looking forward to your questions.
Yeah, thank you very much, Felix, for this very interesting and very excellent presentation on soil moisture modeling and also the insights into land subsidence in southern Vietnam. Yeah, so is there any question? I think Kai and Renny or Patrina, you are sitting in a larger room with plenty of people there. Perhaps you can then also point out when somebody is lifting his or her hand. Yeah, any question here? So if there's no question in the moment, I just would like to ask you, Felix, what do you see now the situation in Namibia in so there's a more important question from Yazid. Yazid asks, now I have to look whether I can. What values did you get for Kunsat?
You mean the unsaturated K unset, I guess. So for the unsaturated hydraulic conductivity, as I mentioned before, I
Yes,
just used standard parameters for clay for the Van Genuchten model, but I will take soil samples and bring them to our lab in Germany, where we have a specific apparatus to evaluate unsaturated conductivity in terms of different kind of water content. So as I said, like the model for now is just like a very, very rough start, and I see where I need to carry out a more fine tuning. And for this, I will take the samples from Vietnam and do the, let's say, exact lab analysis on the hydraulic conductivity. And then as soon as I have the data, I will be able to update the model. And yes, I think that's my approach right now.
Yeah, thank you very much, Yazid, for the question. If there is anybody a question, also can write into the MS Teams chat. My question, Felix, is you know the situation in Namibia. You know what we are like to do. Do you have any idea how to transfer your research to our ideas in Namibia?
I think soil moisture in general, or the water content in soil, is a critical parameter, in particular also in mine revegetation. So I think in particular when it comes to the monitoring, it is quite interesting also because I think the electrical conductivity also can help to characterize, let's say, the quality of the water in certain terms. So I think the combination of such a multi-parameter sensor in terms of monitoring mine reuse or mine water reuse could be very interesting. And of course, even though the climate conditions are very different in Namibia than from Vietnam, I think the concept can be transferred, and I think it would be quite interesting to see the reaction of the water content in probably in a revegetation area.
Thank you very much, Felix. There was a hand lifted in the IGS lecture room. Please, Kai, I think that's you, huh?
No, it doesn't. Okay. Yes, yeah, just keep. Um, Felix, thank you very much for quite an insightful presentation. My question has to do more with respect to the method of analysis you used. Of course, it's important and very impressive to see how this kind of research get translated into practical use. But I really just want to inquire if, with respect to the differential equation you used, I would just like to know, for interest's sake, if you have any future intentions of extending that equation, because when I look at it, it looks like a simple first order heat equation. And I would just like to know if going forward you intend to, or if there's other parameters that you would consider to expand the equation to consider maybe second order processes that could also affect the issue of soil moisture content in your study. Thank you.
Thank you for your nice and good question. Yes, I definitely intend to improve the model and also on a level of complexity. As I said, like now I was just converting these differential equation to a simple script and calculated it myself. There are also free software tools available. I think this 1D Hydras model, I think it's freely available. I also just cross-checked it with that. I think it also allows a bit more of a complex modeling. So yes, my intention is I want to compare my model results with the observation data, and as when I recognize that I apparently miss some processes with my model that I can't predict, based on the observation data, then I will of course consider enhancing also the mathematical background for the model. So I will step by step, I will make it more and more complicated as much as necessary, so to say, to model the processes that I observe. So, but what I definitely see as the first necessary point is to also enhance it to a two-dimensional model to be able to model the inflow of the soil, like let's say of water in certain depth, which depends on the inflow of the channels. So I think this will be the most promising approach in enhancing the model to a two-dimensional flow and soil moisture model.
Yeah, thank you very much, Felix, for the answer. Is this okay for the person who has asked?
We have two more questions, Stefan, from the room
Katrina,
here.
go ahead.
We have Sydney, who wants to ask a question, and Prof Theo thereafter in that order. Colleagues, please go ahead.
Good morning. My question is just to find out if in your research you have a control site, and the other one probably is what motivated you probably to pick that site, whether you have set up your equipment and your observation data and everything. Do you have any control site in your research?
I'm sorry, I think I didn't, the sound is not optimal. I didn't really get your point. You ask about the control site?
Yes.
So let's wrap it up from the other way around. Like the reason why I do the soil moisture modeling on that side is because I want to understand the processes that I can observe in that very specific location where we have this subsidence observatory. So we're having the subsidence data, or let's say in the final slide, where we are having the first time the chance to see where is the subsidence happening in this very location. Of course, it might be changing from this location to another location. This we can use, we can evaluate by looking at the satellite data where we have aerial data. However, what I'm interested in is in understanding the detailed processes on that very specific site in detail in order to identify the relevant processes which are triggering the subsidence. So we see that here there's like a relevant part of the subsidence happening in the unsaturated part. Groundwater level is around 15 meters below ground. Or at least we saw from the dynamics that it's actually happening in the upper 20 centimeters. So the key question of my research is what is triggering the land subsidence? And from this, I look at one site in very much in detail. I think I mentioned before, in Vietnam, there are very many ponds and lakes. And of course, all of this monitoring data highly depends on the location that I chose. So if I go somewhere else where are probably no lakes or no ponds, we will not see effects like what we see here. But in general, my principal aim is not just monitoring and modeling soil moisture, but it's always linked to the implication on land subsidence. And as we set up that subsidence observatory there, I would try to understand the processes in detail on that one site. And then trying to identify the main drivers and then being able to extrapolate that findings to other regions in the Mekong Delta and to other delta regions worldwide. So I'm not sure if this is what you meant with the control site, but the principle behind is I just want to look at one side very specifically, identify the drivers, and with these drivers that I identified, I want to extrapolate it to other regions. Probably I find out that soil moisture, that we're having a high organic content in a certain layer, and this is the relevant parameter triggering subsidence to a certain degree. So I think I have to wait a bit more until I see what really are the main drivers, and then I will be able to extrapolate the data to other sites, and then in these terms I can set up other control sites.
Perhaps I may add a little bit here, because we also have 5 radar reflectors with another group installed. Radar reflectors to analyze the land subsidence via satellite measurements. And you have seen in the first picture from Felix that there's also a radar reflector directly near to the land subsidence site. So we can not for the different depths, but in general for the land subsidence at the surface, we can transfer our results also to 5 to 4 other sites, and to bring our results also in the area. Okay, thank you very much for that good question. Patrina, you have another questioner.
I think in the interest of time, we might need to move to the next presentation. Then we can revisit the discussion on the earlier presentation by Felix. But just to appreciate you, Felix, sharing the work you're doing. And I'm sure there will be a number of follow-up emails directly from our students that are doing work that is related to your area of focus. Thank you so much. At this point in time, I'm just going to hand over to Prof Theo to take over and make his presentation. But from our side, we don't have additional hands. Whilst Theo is setting up, maybe we can take one more. Over to you, Stefan.
No, I thought you have two persons who would like to ask questions. So therefore, I think the analysis are quite important also for the cooperation together with Theo, because we have been in Namibia last year in April, and Felix also in February, and Felix accompanied our team, and we handed also over one of our soil moisture sensor, a little bit another technique to you, and I hope that we have the opportunity to work together in future much more. Perhaps one last question to Felix. Could you just perhaps say something to the manufacturer of that soil sensor? Who is it and how does it work, the soil sensor?
Yeah, it's a sensor manufactured by the company called Campbell. And yes, I obtained it in Germany and brought it to Vietnam in the airplane. That was so far no problem. And it's linked to a data logger. And the data logger is equipped with a SIM card. And in this case, it's quite convenient that also the weather sensor is from the same manufacturer. So we're having only one data logger, which is just logging the data and sending it to Germany. But it can use the data from that sensor as well as from the weather sensor. So in that case, it was rather convenient. It was I think in a comparatively fair cost benefit ratio. So we're having so many data points that we obtain in one hand. If we would think about just buying 8 sensors and installing them in 8 different depths, we would have much higher costs compared to that profiler, which I think is quite of a suitable solution if you're interested in vertical processes. So in case you are interested, it's called a Soil View 10. I think there's also an example which is just 50 centimeters deep, which will be also cheaper in that case. So I think it's a quite of a handy setup of a sensor to evaluate processes in a vertical scale in the unsaturated zone.
Okay, thank you very much, Felix, for this information in depth. So can we hand over to Theo?
Yes, you can hand over to me. I'm just trying to get. I'm just trying to get my presentation open, Stefan.
Yes, take your time.
You just have it stand here.
What must it be on? Can you just set it up?
Okay.
Get it onto the screen share and so on.
Stefan?
Yeah, Theo.
It's Kai. Oh, sorry.
Sorry.
I just wanted to give a quick comment. Oh, is he starting? Okay, then it's fine. I come later too. But Felix, you will not win with your boundary conditions at 20 to 30 centimeter depth, so you need to change there. But let's discuss it offline. Thank you.
Okay. Okay, I think I will start. Somebody other side, just shout out if you can hear me. I just want to make sure. Because I cannot see anything about what's happening on the other side of that screen. Stefan, Felix, are they showing yes?
We see
We hear
everything
you.
and we hear you. Everything is okay. Just start. Nice picture. I love it.
Can they see me?
Can they see you? Let's see.
Okay.
We
Yes,
also see
they can.
Theo.
Oh, excellent. Then I better.
That camera is focused on you.
Okay. Felix, it was very nice seeing your data. I definitely have some questions. I've been spending the last few days working, writing up the data from the Decagon volumetric water content sensor that you left with me. So I've got some interesting things there that I would like to take further with people who know a lot more about that than I do. But anyway, so my topic then is about ecological. I see the notice went out, rehabilitation. I'm not going to go into that again. I don't have the time, but I prefer the term restoration, ecological restoration, simply because it's a more all-encompassing term. It does allow for other things like rehabilitation, remediation, revegetation, and so on. But it focuses more sort of on the whole spectrum of an ecosystem, meaning composition, structure, and function. And depending on our goals with a restoration project, we may want to focus more on the function, in which case it becomes a rehabilitation project. Not that we have to get tied up in terminology, just to make it clear what we're talking about here. So the arid zone, full of challenges and opportunities. This is a picture in that I took in the Marienfluss last year at the end, and probably still going on, quite a severe drought. You can see this little, it's an annual grass. It's supposed to have some living plant material, but it's standing on long legs of roots. All of this soil is gone. So there's a huge need for restoration in the arid zone. When Flavia asked me what will be my title, I thought, okay, let's look at it from challenges and opportunities kind of thing, because it's so easy to just get lost in the despair of how much environmental degradation is going on. But all of those are also opportunities. So I thought, let's see what we can do with it. I'm unfortunately going to have to get into a little bit of technical stuff about challenges. We can group them as being ecological, climatological, and me being an ecologist, this is obviously where I know a fair bit about, not so much about the climatology, but in terms of driving factors, certainly. And then there are others, politics, funding, governance, things like that. I'm not going to go into that today. I'm kind of scared of politics. So I walk long distances around it. But it is something that we have to understand better. And certainly I've got a project that's now loading that is going to be including quite a lot of aspects of that. And also social, ecological systems and social aspects, cultural aspects around this. I'm quite excited to actually tackle that challenge head on. But for today, let's not go there. So in terms of opportunities, there's a lot of opportunities currently, especially since ecosystem services are being recognized more often as a valid reason for restoration. This is really something that's been growing over the last, I'd say, 5 to 8 years. It never used to be like that, but there's a strong emphasis on that, and I'll tell you about it a bit later. There are a lot of these big, hairy Rio Convention-related initiatives like the land degradation neutrality, which is under the UNCCD. There's several under the UN CBD, the Convention on Biodiversity and on Climate Change, that touch on and sometimes directly address the need for and the opportunities that can be created by ecosystem restoration. Not only in the arid lands, but because arid lands are so vulnerable to environmental degradation, there is a lot of emphasis on it. Funding opportunities are also increasing. There's the Land Degradation Neutrality Fund, which is directly tied to the Land Degradation Neutrality Initiative. That is more like, this is not a grant system. You can go and borrow money from them at good rates, etc., and restore your land. And these things are growing. The Global Environmental Fund has a strong emphasis. There's currently, Namibia is preparing a fairly large ecosystem restoration proposal to the GE. And there's another one, biodiversity offsetting, which I'll talk about a bit later. Okay, so, sorry, what was the last bit there? Okay, public works. In fact, that is something that I am very keen to explore in the future. It's sort of close to my heart, this idea of using these opportunities for our public good. Why is restoration in arid zones a challenge? Now, there's a quote from Palmer, I think it's Laura Palmer and Stewart. According to published findings, restoration projects that have been rigorously evaluated are typically, they're called restored, at 0 to 30% relative to reference conditions. That's staggeringly low. And it doesn't really matter how you formulate those reference conditions, whether you look for specific aspects of function, etc., etc. In general, when we talk about success in restoration, our bar is very low. We can do better, but it is like it is. So, given that, now we are looking at arid zones, where there is, of course, extreme lack of water, extreme temperatures, high evaporation and low humidity levels. So that just translates to the fact that plant survival rates are low, and a restoration project, the success turns on how good you are at keeping plants alive for at least 3 years. So with these conditions, your survival rates tend to be in the region of 2 to 3%. Which is a big challenge to overcome. Soil degradation, it happens very easily in arid lands, in dry lands, and for various reasons, people like to throw the word overgrazing around quite a lot. Sometimes I think it's a bit unfair, but there's certainly a lot of unsustainable land management practices going on, and I can go on into this topic for quite a long time. So I'm not going to bore you with it now. But a lot of reasons why: increased sedentarization. I just noticed the word that I put in there. This refers to the fact that a lot of what we consider to be sustainable land use around extensive farming, pastoralist farming, is disappearing because a lot of the pastoralist lifestyle is being forced to sit in one place instead of moving around. And this is a major change. It's all over Africa. It's happening all over Africa, not only in the arid zone. But all of this, coupled with infrequent intense rainfall events, there's a high erosion potential. So a loss of soil is a key resource, and the loss of a key resource is this particular one is very difficult to overcome. Then there's something that one doesn't often think about, that arid zones in general tend to have fewer species, and they occur at much lower densities and in very specific places. And you have this problem of, when you talk about restoration, whether it's just rehabilitation, If you are aiming for a diverse, resilient, and productive ecosystem, you need the species in the immediate environment because they've got to somehow get there. That means that you have to replace all those processes. You have to go and find more species. It becomes very expensive. The natural process of recovery, of dispersal, colonization, and establishment doesn't happen so easily. Habitat fragmentation, which is ongoing and increasing, interferes with some key recovery processes, specifically dispersal. Every species is now almost isolated in a kind of small habitat, and they somehow have to get to the new habitat to go and colonize it. So now fragmented situation makes it very difficult. The world's drylands are it's as if climate change is put like a magnifying glass and burning the world's drylands. Because there's a lot of bad things that we expect from climate change is going to happen in the drylands. Most of those changes are going to be negative, and that pretty much means less rain, less soil moisture, more droughts, etc. Then arid zones are often located in developing countries, which means that there's limited resources. Government hardly ever has the funding available to put into nice ideas like sustainable land management, for instance. There's a lack of technical expertise. I can count on my one hand the people in Namibia that I would say they know their ecology well enough to do ecological restoration with a meaningful chance of success. That's not many. I mean, like 5, okay? 5 or fewer. And I'm getting old, you know that, right? I'm getting like now closer to retirement age, and pretty soon I'm shuffling off. Who's going to replace me? And there's also lack of appropriate tools and so on. Anyway, okay? So let's look at a couple of these things in more detail. The challenge of aridity. I think Felix and Stefan have definitely seen this map before, and some of the others as well. When we had our meeting, I love the aridity index map because it so harshly brings home the dryness that we experience. So the aridity index, if you're below 0.5, that's the ratio of precipitation to potential evapotranspiration. If you're below 0.5, you consider it to be a dry land. And look at this hyper-arid zone, it's below 0.03. So we're talking in the region of 3,200 millimeters potential evapotranspiration and maybe 50 to 60 millimeters of precipitation. That's super dry. So that tells us quite a bit about the challenges that the plants have to face. Not just plants, of course, animals also, but in restoring anything closely approximating an ecosystem, you need to look at plants. The region's soils and vegetation are severely stressed with very low minima in soil water content fraction. You could say that, well, this is the way it is. We accept it. We know we're in a dry country, so plants must have adapted to this. Yes, you're right. There are some adaptation, but this condition undermines aridity. If you just think about that. Let's look at a grazing ecosystem, and it gets degraded, loses soil and so on. Now, the first thing a plant must face is getting there, a new plant. The chances of it finding that, because it's occurring at low density and so on, are very small. On top of that, when it gets there, it lands right at the start of a drought. The chances of it surviving are very, very small. So this is fundamentally the thing that we have to work with. When rain comes, it comes in a pulse. There's a short input in the rainy season, and then a long decline in the available water. Most of this is lost to evapotranspiration. Very little is actually staying behind in groundwater. So only those plants that can overcome this asymmetrical seasonal increase and decline will survive to the reproductive stage. And that's what we want. Restoration means we want to reinstate some community of plants, whether that is focused on specific species for eating, or whether it is creating a new ecosystem. We would like them to establish self-sustaining populations. Otherwise, we're going to have to keep on planting. Doesn't make sense. Climate change and the harsh conditions in these degraded systems exacerbate this challenge. Okay, so what do we know about land degradation here in Namibia? The last publication on this was done in 2004, and it was actually called, the title of the publication says, a preliminary investigation, 2004. We're talking 20 years ago that Mary C. and Patrick Lindbergh published this. It was published in black and white, so, you know, that's the map that we have available. I know Mary personally and Patrick, and I couldn't get the original GIS data for this. So it's effectively what we know about degradation in Namibia we see there. There's been a couple of other work. There's like remote sensing work that's coming in and adding it, but there's never been a reassessment of where we're standing. In fact, this has bothered me so much that for some years now I've been trying to get some projects going on this, and by some coincidence, this year we've got not one but 3 projects that have got a strong component of let's assess the amount of degradation in Namibia and where it is located and what the drivers are and so on. This is the Spatial Biodiversity Assessment Planning project. And then TIPIC is the project that has been keeping me very busy, and in fact I'm about to leave for the field on that. Tipping points explained by climate change focuses very much on the Kuruneni region northwest, but we will have a strong focus on understanding the current status of degradation. So there's a lack of good knowledge about how big is the problem. So now, I thought maybe let's just go through 3 points here, just to explain to you now, we're trying to overcome the challenge of increasing survival. First thing that you can do is soil amendment, because soil amendment, in what Felix earlier mentioned, organic matter, which is basically what you want to do is you want to increase the organic matter. That increases the water holding capacity. It increases infiltration and retention. And here's a picture of some mine. I have no idea exactly where this is, clearly not in the arid zone, but just their plan for soil amendment. It involves big trucks and lots of groundwork, and I can just imagine that's going to cost quite a bit of money. Anything that you do where you have to shift large amounts of soil or grounds from one place to another, you're paying thousands per hour for those machineries. So, very expensive. The second thing, we can do water harvesting by building these contour bunds or micro-catchments. That's just examples of plans for that, where you have contour bunds and then small catchments so that you enhance the amount of water that gets to plant life. This one I found on the internet, but I made a very similar design for a restoration project we did in the Congo once. But there, of course, we had to have something to prevent the, wait for this, 3,000 meters of rain that they receive in a year. To prevent that from just washing everything away, so we constructed these big capturing things. And there's a plan. I must go and check one day whether they've done it, that I did for Rossing. They had a big problem with water running just away in a big drainage line, and we constructed or planned these things for them where they kind of capture the water harvesting effectively. And then there's another one where you can do irrigation. There's an example of a project which could clearly show some species respond very well. Survival is very high if you irrigate versus don't irrigate. Each time in these graphs, the solid line is one where they're irrigating, and the other one is a control. Other species don't. That's the kind of projects that we need, because that's so clearly telling us, you know, don't bother with this thing at the beginning. Go for those that are going to respond for irrigation. Very, very simple. That's not the way people usually decide which species to pick. Here's a local example. At Sendlingsdrift, Namibia mine, which I was involved in the restoration planning and the actual installation of these plants. I probably planted that plant. And you can see where the irrigation pipes were. This one is actually on the same site, but the irrigation pipe was just not close enough to it. It's dying. That one is flowering. The chances of that thing making it to 3 reproductive stages, very nice. But that small bit of irrigation cost over 60,000 Namibian dollars. So, it's a challenging thing. And then, of course, we can overcome a lot of it by selecting the species that are going to be better at surviving. Not all species have the same ability. I've put some graphs here, specific leaf area, water use efficiency. You can see that those with the largest specific leaf area have a lower water use efficiency. That's the kind of thing. These are microanatomical features, a very thick palisade layer, and these have got sunken stomata, things like that. We can look at species that have those traits that give them an advantage in those drought conditions. There's, for instance, CAM metabolism. I've got a student currently, a PhD student currently scanning Namibian indigenous plants for those that employ the crassulation acid metabolism pathway, which is much more water use efficient than your normal C3 plants. And then some other things which we don't have to go into. And the challenge, of course, is the cost, effort, and expertise. We are sending our samples away to Oxford for analysis, and these things are not cheap. We're looking at isotope work and so on. Stefan has offered us to do it through them as well, through one of the colleagues here. Okay, then there's these other things. This is the last point here, maybe, is just to say that overcoming fragmentation and chance means that you effectively have to step in and assist colonization. You can see this scene here where at the Sendlingsdrift mine, where there's a vast area that has been like basically denuded. We installed these as trial sites to see, you know, just to kind of test what methods will work best. And then we eventually ended up with using a big machine. It's the weirdest feeling coming from a ecological background. And suddenly you have to stand there and tell this machine operator, no, move that thing over there. Not there, put it there. It's this scale up from thinking like a person that's just planting with a, you know, like digging a small hole, and suddenly you're working with that. And so we had to create these islands of fertility. There is some soil amendment happening. In fact, that's precisely what that thing's doing. And we planted the plants in there. And to all accounts, it has worked with the help of irrigation, but it's quite an expensive exercise. So that's now sort of a couple of the challenges. Let's look at the opportunities. The ecosystem restoration has the potential, this is a statement by Sewell et al. 2016 already, ecosystem restoration has the potential to combine the global policy agendas of biodiversity protection, climate mitigation, and food security. And if you keep your eyes open, you'll see statements around this particular kind of thing quite often these days. There's a lot of emphasis on this. And one should take chance, you should take the opportunity when these things happen. We're currently, in fact, in the middle of a decade of restoration called by the UN, 2021 to 2030. And they produced these very nice images showing deforestation, industrial agriculture, overgrazing, and loss of biodiversity basically means loss of livelihoods in the end. And by coming in and restore the soil and water cycle, you reverse this desertification through erosion control, soil restoration, replanting, etc. You create these intact ecosystems. At least that's the idea, right? And it's growing. There's a map with what they call regenerative projects going on around the world. You can see that, well, I hope you can see that sort of the earth spread out like that. Africa is hiding, I don't know, somewhere here. And you can zoom in on each of those, and then there's a little write-up on each of those projects. So there's a lot of growth. It didn't look like this 8 years ago. So the big, hairy Rio Convention things, funding is growing through the LDNF and the GEF and other similar things. With many of those projects are focused on arid lands because of the extra vulnerability. Here's an example, local example of ecosystem services that could be a good rationale, not only for conservation of an area, but also restoration. The Windhoek aquifer is huge. It has a lot of water. It could take us through 2 droughts, I guess. It's just going to cost a lot of money to pump that water out because it's quite deep by now. But if you degrade an ecosystem like that, which is a photo I took just over here in the Awas Mountains, that basically means that whatever water is going to get on there is going to run off. It's not going to penetrate into the aquifer. So there's a huge incentive for this ecosystem service of clean water to restore degraded ecosystems like that one. If you have a good cover of annual grasses there, your infiltration rate is 3 times more than with a sparse cover or no cover. So that's a good example. We are currently working, in fact, on kind of developing policy. I've got an honor student on that project at the moment, looking at policy for the city of Windhoek around how to use this and how to, restoration will definitely become part of one of those things. Then there's biodiversity offsetting. I'll give you a moment to read that paper quickly. Shall I just wait for a few minutes?
You're counting on sharp eyesight. You're blind.
No, I didn't know. How do you illustrate policy? It's always those photos of people, those idealized photos of people sitting by a desk and there's sun coming in from the side and they're smiling and things like that. They're writing a policy or what. I don't know. I couldn't think of how to illustrate the policy, so I thought, this is the policy brief that I wrote for Ministry of Environment and Tourism at the stage towards biodiversity offsets in Namibia. Now, why I'm saying this is that you need to know more about biodiversity offsetting, and I'm not going to go into that, but the idea is that if you work on the mitigation hierarchy in environmental management, then offsetting is one of the ways in which you can bring your impact to the environment to net zero. The remaining impact you offset by going to protect another piece of land. So a mine typically would do something like this. We cannot do that because our country is already in close to 50% so-called protection, some form of nature conservation. That's a lot. It doesn't prevent us from mining there, of course. So it's impossible to now say, let's make a protection zone, a new protection zone, to protect us because somebody may come and mine it. So one of the recommendations in this policy brief was to define restoration as a potential offset. It's globally recognized, and so this creates a lot of opportunities. And I'm almost done, but I'm coming now to the bit that I'm really excited about. I'm sorry that I'm taking too long here. I'm so sorry. I tried to delete slides, it didn't work. One of the options is to investigate the potential for rangeland restoration to become a biodiversity and a water security offset for impact mitigation. A large part of Kunene looks like this. If a mine wants to mine somewhere and they say the impact is too large, do an offset. Say, why don't you put it into a fund, a restoration fund, that we can go and support communities over there. This will not only create, if you restore them successfully, or at least to 30%, then you will reinvigorate that livelihood, but you'll also create water security. Because a healthy ecosystem is where you'll find the clean water. All right, so I'm going to just rush over. Then my last bit is the public works thing that I mentioned. I already mentioned this as a potential for this Wamina project phase 2, whether we shouldn't include this. I'm strongly feeling about this. There's a project in South Africa called Working for Water. They've been going since 1995. Right? Yeah, somewhere around there. So for more than 25 years anyway, they've been pouring government money into a public works program where people go out and they restore catchments. They basically remove all the alien vegetation. It costs a bit of money, but if you look at the advances in water conservation, it was a drop in the bucket, that money. The benefits have outgrown the costs by a huge amount. Now, they've extended that to working for wetlands, and I think there's 1 or 2 other related projects that came out of that. Now, I'm thinking we should look at something like that for our abandoned mines. We're not going to have that benefit of fresh water coming out of it. So we'll want to look at big grant funding, looking at the Jeffs and those kinds of people in the world. But that will contribute a lot. There is Klein Alp, a community of about 5,000 people, I think, 2,000 people, living right next to this huge, unrestored, unrehabilitated mine waste dump with literally almost no economic activity going there. So it's kind of ideally made for a project like that. There's Brandberg West down in the desert. There's also another option is if you can plant biomass crops on these things. You can sell the biomass for energy, for food, for fodder. We have a big project focused on biomass here in NAST at the moment. Okay, and that's it then. Thank you very much. I can summarize, say, arid land restoration is a huge challenge for many technical, ecological reasons. There's also systemic challenges like political interference. I didn't go even into the perverse incentives. You can write a whole story about that. How we are structured to we talk the talk about how we want to do sustainable land management, but we create incentives for people to do the opposite. There's lack of resources and capacity. And each and every one of those challenges can be overcome. I like to quote myself by saying I can build a rocket to fly to Mars. All I need is the time and the money. And thinking that Elon Musk is the guy that wants to fly to Mars, you also need to buy Twitter from him, I guess. A lot is being done already, but a lot more can be done. So it's lots of opportunities for the next generation. Thank you. That is it.
Thank you very much, Theo, for this comprehensive and also interesting presentation from the political point of view. So a little bit more from the bird's view, which is very important also for our project to consider this kind of bird's view about all the conflicts also we have with revegetation issues. Thanks a lot. Any comment here? Any question? So I would have one, Theo. You know that also human beings are that human beings are influencing the landscape and also the vegetation patterns in countries. In Germany, we have two kind of vegetation maps. One for the natural vegetation, which would cover Germany without human impact, and one vegetation map, vegetation pattern map with a human impact, and this is quite different. How would it like for Namibia? Do you have any information about that? Also, it's not only since I think also since centuries, thousands of years, human impacts will be affected the vegetation in Namibia. Do you also have something like this? The comparison between the natural vegetation patterns and the human impacted vegetation patterns, and is there really everywhere where you have now vegetation also, if there would have been now human impact, would be there some vegetation? How is the influence of human beings on the vegetation patterns in Namibia?
Is there anybody else who wants to answer that? That's quite a big question, Stefan. First place, I need to just say that I don't think that it's not a fruitful way of looking at it to say, what would it look like without human beings? Because human beings have been part of Africa since we have been Homo sapiens and before. So taking us out of that equation doesn't really come to natural necessarily. We have to look at other criteria here, maybe highly technologically, or cultures or communities that use technology. That could be one way of looking at it. But there are no maps like that. I think that it would be extremely difficult to make a map like that. I mean, the human impacts on the southern African ecosystem was minimal for thousands and thousands of years, and I don't know how one will be able to actually get to something like that. So the short answer is no. There's no map like that.
Okay.
So nowadays become, of course, that places like Kunene, which have been enduring drought and supporting livelihoods for at least hundreds of years, where people were using grazing practices that were adapted to this arid system. That has changed. Global change is driving us into a completely new world. The sedentarization, which I mentioned earlier, means that people just don't have the freedom anymore to move anywhere that, or when the time comes. When it rains, you take your animal somewhere where there's now food. That's not possible anymore. And these kinds of changes mean that we are starting to experience severe impacts on the ecosystems there. It's also in other places, of course, but especially in that area where water is exceptionally scarce and droughts are intense.
Okay, thank you very much, Theo, for that answer. There's another one from the IGS lecture room, and after that, Abraham has raised his hand. So first, perhaps the IGS room.
that other side.
Thank you, Doctor, for quite an inspirational presentation on ecological restoration. So my question really has to do with the issue of policy and decision making to facilitate the protection of these environments. And from what I really understand from the talk you gave, the very insightful talk you gave, it seems that the factors that cause degradation will continue to intensify over time. And that makes sense that recovery continues to be more difficult, giving it a 0 to 30% recovery rate on average. So I would just like to know if, specifically for the Namibian case, there's any predictive capacity currently being developed to assist in these regards. As in, we look at factors like deforestation, decreased plant survival rate, soil erosion, bush encroachment, and salinization. So I just really wanted to inquire if, besides the great work that you guys are already doing on the field, if there's any predictive capacity to kind of ascertain the levels at which all these parameters contribute to the problem, and how a predictive capacity of some sort can help in the mitigation attempts. Thank you.
Thank you very much for that question. Maybe just explain to me what you mean by predictive capacity.
So I understand that there are several studies that have tried to understand how these factors all interplay with each other. I've seen different sorts of mathematical models that kind of describe invasion of species that would not be very favorable to soil conditions and things like that. So I know also that different studies have sort of looked at the capacity of survival of different species, where they would classify some as predatory and some as can't really remember the name right now, but really I've seen studies with mathematical models that sort of do this kind of work. And I was just trying to see, I was just really interested in knowing if there's any of such kind of work being done specifically with the Namibian case study that you've presented. I'm not sure if I might have made a little bit of sense.
Yeah. Thank you. No, that's a very interesting question. You're making me think a bit. Yeah, I mean, I just have a short answer and say no, there isn't. But there probably are a lot of kind of isolated studies that nobody's really gone and summarized in a way. In terms of the actual capacity to do these things, I would say, like I said in the talk earlier, there's about 5 people that I know that are sufficiently trained in this field, and not even necessarily in sort of modeling fields like that I would say, they can make a meaningful contribution to that. So there's very few people. There's definitely lots of opportunities to improve on that. Those studies that exist, I think they are probably very specific case studies and so on. And what we need really is a big overall view of them all. I hope that answer satisfies you, or at least in terms of it's an answer, maybe not a good answer, but.
Okay, of course, thank you for the answer, and it's quite unfortunate that such studies are not currently going on. Actually, the real reason why I'm asking the question is because scarcely reading on material, you tend to realize that these factors that cause soil degradation and at large impact the ecosystem tend to have loop effects, as in feedback mechanisms where one parameter seems to impact the other in one way. So you might end up focusing on solving the problem by looking at a specific way, and then just to realize that that approach is being affected by another parameter which has a sort of feedback mechanism effect on other parameters. And if you don't look at it in a more holistic, robust fashion, you might end up with the situation that you very, very well highlighted with the low success rates that we are achieving. Of course, that there's a bigger problem to it, which is of course climate change. I just really was interested in the modeling aspect of it to know, because typically that would go a long way to inform policy and other governmental incentives that are supposed to be involved broadly to solve the problem. But thank you very much. Thank you very much.
Thank you for that question. I think it's a very valid point, and especially, yes, well, one needs a systems view on something like this. This idea of the feedback loops, where there's a positive or a negative feedback. You know, if you take that approach, I think in the end you have a higher chance of success. You manage to pick out those particular keystone things. Anyway, I think it's another subject for another discussion. It's very interesting. I think there was another hand here, Stefan, right at the back.
I think also the time is running, and we should end finally here at 10:30 because we all said it should not last more than 1 hour, and now it's already 1 hour and 20 minutes. So, Abraham, I think it's your turn to pose your question. Abraham Kanime.
Thanks, Prof, for such a insightful presentation on ecological restoration challenges and opportunity. I must appreciate the challenges that you have highlighted. And I think at this point, it should be a common acceptance that if environment is disturbed, it will be a challenge to bring it to its original shape. But my question on that was just on the policy guidance. If perhaps in Namibia or in SADC, there is a policy guideline in terms of classifying the restoration that is required for each of the disturbed land, so that perhaps when one take initiative to restore certain areas, then you are sort of guided to say you classify your area into this zone, and then it will go with what is required, whether it's from a legislative or a policy guideline, just as best practice. The second one, I just wanted to, it's for interest, you have shown that there is that area that is sort of a strategic protection area for groundwater for City of Windhoek. I just wanted to understand what is the ideal outcome of this protection? Is it just protection from the non-point source of pollution, or does it also cover the aspect of non-point source of pollution? I mean, what I mean by that, is it like just to declare the area a no-go area for development, and is there additional intervention around, putting in system either to divert wastewater runoff from other areas so that doesn't enter that zone, or how does it work, or how is it planned to work? I think those are a few comments in terms of maybe because of time. Thanks.
Okay, before I answer, just can I just have your question quickly? Then maybe I can answer that as well, because otherwise we're going to run out.
No, thank you very much, Professor Theo, for that comprehensive presentation that's focusing on ecological restoration, the semi-arid zone, looking at challenges and opportunities. I think my question also lays at the back of the other previous person who spoke, who raised the question as well. Just out of interest, to your knowledge, have there been any studies or any study undertaken on the economics of ecosystems and biodiversity for semi-arid zones? Because I feel that such a study could also help to inform policy and maybe also serve as a motivation for unlocking funding to invest in this restoration process, while also as well helping in prioritizing the areas that would make the biggest bang for the buck that's invested. So that's my question.
Okay, thank you. To Abraham Kanime, then the first thing was, now I've forgotten what was the first issue. Oh yes, no, we don't have specific policy or guidance or classification schemes for things like that. There have been a few attempts at producing best practice guidelines, things, but they're always very specific into one particular area and so on. So no, I don't think that there's a lot of opportunity to improve on that. The second question was about the aquifer. I'm not the person to be answering that in detail. I know it only in the sort of broad sense. The idea behind it is fundamentally protection against point source pollution, maybe non-point source as well, but keeping development off it. But there is opportunity that non-point source pollution can reach it. In fact, it's one of the things that needs to be looked at. My interest in it comes more from the actual keeping development off so that we have best infiltration of water, because our aquifer is super important. We're already starting to run out of water from Bach Dam. By June this year, we will have water restrictions, mark my words, here in Windhoek. So we have to have this aquifer with clean water in it. And it's from that perspective that I get as much water into the ground every rainy season as possible. So yeah, there's still a lot of work that needs to be done on that aquifer, by the way. And then the last question, there is in fact quite a bit of studies, quite a few studies going on the sort of economics of biodiversity, the economics of biodiversity and ecosystems. There's a strong emphasis on the GIZ has been funding a couple of projects on this. They had a resource mobilization project a few years ago, which has now gone over into the biodiversity economy project. So they have been putting in. I'm not saying enough's been done. I don't know that field well enough to say. And I do agree that the more we know how much value these ecosystems add, the easier it is to justify an investment into creating or to protecting them and utilizing them in the proper sustainable way. Is that okay? Okay. Okay, thank you, Stefan.
Yeah, thank you, Theo, and thank you, Felix, for these both wonderful presentations, which helped us a lot to understand our ecosystems more. And so just to bring both presentations together, we should just combine the soil moisture sensors with the drip irrigation so that we can automatically irrigate the plants in the semi-arid and arid areas. So it fits quite well together here, our presentations. I think we should now come to an end. I, from my side, thank everybody coming here into our online lecture for the participation and also for the contributions of questions. Thank you very much. We will hopefully have, I have to discuss this with Reni, Patrina and Flavia in 2 months, another lecture. We will inform you early enough. And since in the moment NAS is also the host of this lecture, I would like to hand over for the last closing words to Reni and Patrina. Thank you very much.
Thank you so much for this. Let's give a hand to our speakers and really to applaud Professor Stefan Doerr for facilitating today's discussions. I truly want to applaud the teams at NAST, specifically the Directorate of Research, Innovation and Partnerships, Ms. Kuda Brandt, who was working behind the scenes. We have a number of celebrated people who will be working towards this seminar series, and the same is true from the University of Potsdam, Flavia and the team for the work they've been putting together. So without much further ado, just to wish everyone a pleasant afternoon and looking forward to our next public lecture or seminar within the MiWaNet seminar series. Have a good day. Thank you. Thank you to our online participants.
Goodbye. All the best to you.
Cheers.
Bye.
Goodbye. Well, I will link you up with Sylvanus. I think you will appreciate this. There's paper studies that I think around. You're happy to find what the research applications around.